instead of using formatter, if you want, you can also use print writer. It's just another library that you can use to write some data to the file. So what is this? Well, again, you just need to define print writer. Let me delete this part. New print writer, and then it will come with some new parameter set. Like for the print writer, okay, we can use, for instance, again either the string file name or the new file or a file object. So again, I can just say then as an output.txt, and I don't want to forget, and we have to do it again within try and catch, and I don't want to close it, so I will put it also here. And then, well, it also has these very similar features, but the function name changes. It's not format anymore, it's print. And then you can print some Boolean variables or strings and so on. So this is again just another function that you can use to write data to file. So if you look at our code, then it will say false, this Boolean variable that we put, and then the ABC. So this is again, which one you should use? Should you use formatter or the print writer? Well, it's really up to you. Like which one you know best, you can just go with that. And now let's look at the example given in the slides. So let's look at this now. We have this buffered reader to read from a file, and print writer out1 and out2. So we want to create two different files. And now we create these two files, out file 2 and out file 3. In one of them we use just a string, and the other one we first create a file object, and then we create it. We give this as a parameter to our print writer. And in this code, what we are doing is we are going from 0 to 10. If it is an even number, we write it to some file 2. If it is an odd number, we write it to some file 3. And then we need to close both of them. And then we open our buffered reader by using this file reader. We want to read this some file 2. So we read it line by line. We say that line is first null. And then here is this context. Maybe I didn't show this part. Do you know what this means? While, and between the parentheses, we say line is equal to in.read line is not equal null. It's not empty. Yeah, we are checking if we reach the line, but we also put this here. This is equivalent of what I have written, but usually, like some people, just to keep their code in a tighter way, they write this first one here, line that equal to not in that read line. So we do this reading next line within the while's condition. So when we write it, it first reads one line, put it in this line object, and then check if it is null or not. So it's, in my example, what I was doing is I had first read one line for the line and then check if it is null. I did my operation, and then I had put one more line to read the next line. So instead of doing it here, they put it here so that the number of lines of our code will be less, but actually from a functional perspective, they are exactly same. All right. This is the last part of the I/O operations, binary operations. But before going into that, I want to do another experiment on reading files. So what is this? Yeah, I will write some data so I can keep it. So when you are writing to a file, or maybe you need to be careful about it. It can significantly affect the performance of your application. And we will do one experiment. First, it will be against our expectations. This is a spoiler. Then we will fix that, okay? So let's say that we'll do an experiment here, just to understand how it is fast, okay? So I would like to calculate the execution time. So that's why I will first keep when my application started by using this system current time malus. So this gives the time when this code is executed, okay? And I will also use another code to get it. In between here, I will put my code, okay? So I calculate the time, I will do my operation, and I will calculate the time again. And then the difference between these two times will be my execution time. So it will be basically end plus minus start, give me the execution time. Okay. So what I will here do is, let's say I have a string s, which is empty. And then in a for loop, let's say I want to print it 100,000 times. I will add this number, just this string, that's it. And then I will write it to my file, this string, okay? So this is one option. This happens a lot when we have an application in which we have to frequently write data to a file, okay? So let's say that in our application we need to do some operation 100,000 times, and then at each step I need to write it to the document. So there's two options to do this. The first one is I can keep all the data that I want to write to the file in a string, okay? And then once I am done, I will just write all of them at once. So this is the first option. This is option one. And the second one is, I'll do a very similar thing, but at this time, what I will do is, I'll change my code here. Instead of keeping it in one big string, whenever I need to print it, I'll just print it. Okay, so this is these two different options. So first, I will close this and check how much this first option runs. Okay, so this is the option 2. All right, and I'll just now run the code and see what will be the output. Okay, so it says that the execution time is 741. I want to keep it here, so I will just take as a note here, okay, 741. Now let's go, what will happen? Will it be faster or slower? What do you think, this option, the second option? We are printing exactly the same data, by the way. So it's just 100,000 times 0. Which one will be faster? What do you think? The second one will be faster.
Should be the second one, because we're doing two tasks at the same time, printing and processing. Printing to the file and processing. Instead of processing and then printing.
Any other idea? No idea. You won't get an output. The second one. Okay, let's see. So I'll run the code again. Now it is 56. So yes, it's more than 10 times faster. But actually it was against my expectation. Why? Well, because I know that writing to a file should be slow. The other one is just, I'm doing the operation on the RAM, but every time, like this is the difference. Here, I'm going to the disk only once. I'm doing all the operations here on the RAM. But in the second option, I always keep going to the RAM 100,000 times. So this was normally, our first intuition was, of course, this wasn't the case for you, but like it might be slower. The reason is, okay, then I'll have a third option, okay? So I'll also close this. And as a third option, we didn't see this in the class. It was in the as an optional slide when we were seeing this topic, the string builder, okay? So the string builder, here is the case. What I will do is, again, we will do it this much of time. And we will, at each operation, we will basically append this same string, okay? And then at once, we will print the same string, which is, what was the function name for it? I think toString, I guess. Yeah. So this is the another option. Again, the only difference is that now I'm not using the string class. I'm using the string builder class. But at the end, I'm still writing the same data. And then let's check how much it will take time to run it. Now it's 38. So we can actually, for those operations, we always need to run it multiple times. So it's 22, 22nd, 29, 25, okay, around this range, around, let's say 29. But it is now 2 times faster than this. So now, what is happening? Why is this faster? Why the third option is the faster, second one is the runner-up, and the first one is the least one? Well, here is the explanation. Normally, I/O operations are slow. Like whenever you doing an operation in a RAM and on a disk, it can significantly slow down your process if you frequently access your disk, because it's a manual, it's a physical process, not like the RAM. So actually, the main goal is to reduce your operations as much as possible, your I/O operations. So that's why in this string builder, it is faster because we are using RAM. And instead of going to the disk 100,000 times, we just go once, so that we just need to detect the location on the once, so that this is the reason that this is much faster. But then, of course, then why is this slower? Because we are still doing it in the RAM, but it's much slower, like 10 times slower. Well, this is, do you have an idea why it might be? Like the string class is much slower?
Because we are appending each time to the volume and everything.
Yeah, we are also doing it here. We are also appending here.
We want to see the string builder, how it works. We can't see how.
So if you remember, strings objects are immutable. They are not changed. You cannot change the value. Once you create a string, you could say that, okay, S is A and then S is B. Yes, but actually internally it's not changing the value of string S. It's just creating one more string. So if you keep appending the string to some text to your original string, actually it's keep generating new strings again, more and more and more. So our memory is filled with many strings actually when we are doing this very simple operation. So because of that, it becomes very slow. Doing the memory operations becomes very hard because we are keep creating new strings, and then our memory becomes filled as the process continues. At some point, it will be very hard to find an empty space in our memory, so that this is much slower. So this is a very specific case, but normally, yeah, our operations in a RAM, if it is implement it in an efficient way, we expect that it will be much and much faster than the I/O operations. This is important. Why? In real life applications, let's say that if you have this kind of a for loop, like you think that, okay, this happens if you work on a machine learning problem, AI models and so on. You are dealing with large data, and then you just put some some print messages just for debug processes, and then you are expecting, okay, your code is still running, it's 30 minutes, 40 minutes, it keeps running and running. Then if you just remove those print messages, then you'll say, okay, it's just run in 1 minute, maybe. So these things might happen. So in short, when you are dealing with the I/O operations, you have to be careful about its efficiency. It might significantly reduce the speed of your application.